Folks, welcome back to the channel. In today's video we're going to continue with the basics and make some adjustments to the box that we made in the last video to make it more machinable rather. As it is now, this would work fine as a 3D printable box, but if you want to make it out of aluminum on like a CNC machine, or even draw it and make drawings for it and manually machine this, a lot of these features won't work, such as the grill. Also, we're going to make the box a little longer since the minimum length of certain cables dictates that. So let's start with the length of the box. So we're going to hide the lid since we don't worry about that right now. Make sure your base is active. And we're going to go back to our very first sketch. So remember this sketch where we made it 110 millimeters? Let's make this say 150 millimeters. So that makes it a little longer. Click Finish Sketch. And you'll notice, because we constrained everything in the beginning of the design, all these holes haven't changed. So we just gained extra space where the USB ports are. All of our holes for threaded stuff, it's all there. And since we derived the lid from that, the lid has also been adjusted without us having to change anything other than that one setting in the original sketch. So now that we have the size done, we're going to hide the base and we're going to look at this grill again. So I just clicked one of the features there just to find that grill. And as you can see, parts like this is too small to machine. And there's a lot of rounded areas. So what we're going to do is, on this portion, we're going to measure what the size is here. And it didn't measure right because we need to show snap points. So it's escape and I click, make sure that's clicked. So you click that point and this point. That's 1.5 millimeters. We're not cutting that. So what we'll do is, in the extrude for that, whoops, wrong one. Which one was that one? That was this extrude. Was that one? No. This one. We need to find. There it is. That's it. Alright. So what we're going to do is we are going to uncheck that one, and leave those up because they're not machinable. If you look at, also if you hold down Control when you see these arrows, they'll stay visible so you can select them. So that's 2 millimeters. We can work with that. We'll use a 1 millimeter end mill. But we do need to address these corners. So we're going to apply fillet. So hit F, and we're going to fillet everything. Alright, we have them all selected now. And now we just get to play with some numbers and see what we get. So I'm going to start with a 1 millimeter. That looks good. You could probably go up to, and then if you get too big, it gives you an error, won't do it. Like 0.5 millimeters. But we're not doing that. We're doing 1 millimeter, because I feel that provides a nicer contour look. So you click enter, and that's done. So now that that has been fixed for machinability, we can move on to adding the ports that we were talking about in the last video. if you could remember last video, we couldn't add the McMaster car parts since there was a issue with maintenance. So now that it works again, we can add a part. So you go to insert, and then you click on insert McMaster car component, and it brings up this list. So I believe we wanted a Cat 5 pass-through. So let's see here, Ethernet panel mount. I use a particular one a lot, which looks let's see here, I got one on my desk. Yep, this one's right here. I use this one a lot. So we will grab this, we'll click on 3D step and click download, and now we have the part in our in our drawing. There we go. Alright, so we click that, and let's add a power port. And so DC barrel panel, and then we just scroll down to see what we want. Let's see here. Yeah, let's just use USB panel mount, because honestly it's going to be powered by USB anyways. It doesn't matter. So we want a couple of them. We want some for outputs and some for inputs. So let's add a standard one. These ones come with a plug on the inside, which can be nice. So, but for this situation where it's a really small box, you can be cutting the cable. But we still want to have the A connector. Let's make it USB 3. And this one's a simple pass-through. And let's see if there's anything smaller we can use. Okay. Let's just use a simple pass-through one then. I really wish you could make this box bigger, but I haven't found a way to. So this is a cable to A cable. I'm not really wanting to use that or that style, so we will just use a socket with a plug. But I like that style better. Let's go black for contrast. Since we already added a file today with this open, it'll provide you with that as already pre-selected for the step file. So just click download, and you'll see how that cable is crazy. So we'll be modifying that in a little bit here. Click OK. And then we need a USB power input. So click on that again. Let's see, we'll just yeah, we'll type C this, why not? Type C panel USB. Is that what we're looking for? No, that's not. So let's just do again another USB panel. Click that. And we want to have the opposite on the outside. So we want power. No, we don't want that. Or that. Let's see here. No, we don't want minis. I have used these before, they're just not ideal. I don't really particularly like those. Let's uncheck power and let's see what type C gives us on this. Just that one, so now we don't want that. So this is just something you just have to search through. What I will do is I will not bore you. I will just find this for it, and let's do a micro USB. There we go. Maybe not. Okay, now that we have these parts, we're gonna move them outside of this because I screwed up. And click capture position, there we go. Alright, now they're outside of that object where we want them. And we need to modify this part. So we will select this one. We're going to expand this, see what we got. Which isn't much. So we will click this button. Actually, no, we won't do that. We need to offset plane first. So first we're going to click this, and then we're just going to move this back to here. Because I'm assuming what we'll do is you would trim this cable and rebuild it as a shorter length. So that way we just click this. We're just gonna click on here for lazy sakes. Click circle. That looks good. Just make it bigger. Click on finish sketch. Click on this, hit extrude, and we're just going to go like this, cut it all off, and there we go. Now we got our little power port. So now what we're going to do is we're going to measure the diameter of this. So I take our little measuring tool. Figure out why it's not measuring, but that's an 11 millimeter diameter, so 22 millimeter hole. So we will go back to our base, and we might have to make this bigger. So confirm that's there. we will place a sketch on this. Make a construction line, mid-plane. Make some points. We got 3 of them we need to make. So say here, here, and here. That way we can do some measurements, make it easier. And that is going to be say 22. And say 22, just for kicks. And we'll make that 22. Let's see here. Those all look about the same diameter. So this is when creativity comes into play. We are going to get rid of this hole right here. And then we're going to get rid of this mid-plane. And that is going to have a, let's go 44. And then make that 22. Extrude. Extrude. And you see it, that cuts that out. We don't want that. That's not ideal. And it's also messing with the fillet. So that's what we would call suboptimal, or at least the kids would these days. So what we're going to do is we're going to Control Z undo that. We're going to finish that sketch for now. We're going to go to the initial height, click Edit Feature, and we're going to make that 35 millimeters now. And everything else updates. And you'll notice the holes update. Now we can click on that again, extrude again, and you click that, and now we have nice holes that are happy. So we're going to do something similar with this side to stick the last connector in. We're going to click on this again, line, and then we're just going to find a point, click that there, distance from the edge, let's do let's do 50. Yeah, that looks like a good place. Just okay, whoops, tried to make the circle first. Drew that out. Alright, now we got our 3 holes. So we add these back in. Click on the top layer. And now we start placing them. Now this will come down to what your plans are. I am personally going to stick the power port on the side, as that's going to have a no doubtly longer cable. So I'm going to click join. I'm going to find a nice circle. Click to the inside one, it looks like probably better. Yep. And hit enter. And that one's all happy and fits. So we're going to do the same for these. Similar. So join. Find the center point. Again, you hold the control button down. And that one, the nut won't look right because it's just how the nut is, but there we go. So the nut's going to clip a little bit here, don't worry about that, that'll change when you tighten it since it's got a lot of room. And then the Cat 5, hit join again, click there. This time we're going to go on the outside, and we're going to rotate this like So, as you can see, there's not very much room, but there's ways we can handle that. That's not an issue. We can rotate some things around. Click OK. Look at the panel, and you'll notice there's 2 holes here now that need to get filled. So first we'll just get rid of this so we just don't see all the joints. We're going to click on base and activate it. I'm going to make a sketch right here, and we're just going to project these 2 holes rather. Click OK, and then we're just going to see what the size is. So that's a 3.5, so that's a, that should be a 3mm, I believe, screw. So we'll just hide all these. Click our hole tool. Click there. Click here. We're threaded, so M3. That's fine. And then we just click OK. And like the other one, that one breaks through a little bit. Shouldn't be a big deal. So we got a lid, we got those, and now they're all happy. So that's about it for the design of the box. And like earlier, if you wanted to, you could just 3D print this as it is. But we're going to machine it. So first we're going to save it. Just make sure everything's saved. And then we will get rid of those. And we're going to do the lid as our example. The base will be very similar. It's just you're going to have more sides you have to set up. So it's just same thing, just more sides. On this one, there'll only be 2 setups. So now we click from design, we go to manufacturer, and it's going to take a second. And then we're going to click on the setups and then right click new setup. And this box right here is really important. It has, so first we want to do the stock. I don't like doing relative because we don't buy relative size stuff. So we're going to use fixed size. And the requirement is for the Z is 10mm. So we're going to use, I'm in America, the United States, so 12.7 because we're going to have to use 0.5 millimeter or 1/2 inch stock. Width is, let's see here, we got the Y on that axis, so let's see here, so let 70s in. Let's do 3.5 inch material. That gives some space there. Let's see here, and I think that would be 8 inch, I believe. No, maybe it's 7. So this part you just have to kind of play with, and be just careful with what you decide as waist stock. Alright, so 6 inches isn't going to work. We'll just do 7 inch stock since that fit the whole thing. Alright, so that's good for the stock, but as you see, the origin is there. So you can use that as your origin if you check both sides on your Y and your X, and that's your origin point. But most people, they just click one corner. So that's what we're going to do. We're going to select this corner, so stock point, make sure that's blue. Click there. Our Z is up, our X is on the right axis, Y is on the right axis, so we don't have to mess with that any. We're not using any fixtures. We can name the program here if we want, but I usually don't do that. Stock's good. So we will click OK. So the first operation you're going to use is you're going to surface it. So we're going to do a face operation. So these are in the 2D. So you're going to click on 2D face, and then select your tool. And it kind of depends what machines you have. I have a few different ones, so. But for this one, I'm going to use my tool library, and I've got a face mill. This is a 1-inch face mill. And I'll turn flood off because it's aluminum. And I haven't adjusted this one for this machine yet, so let's go 12,000 RPMs. Selected box, that's fine. Heights. Now the heights you gotta make sure of. So I always do the side. So you want the height of the material. So top height is stock top. Bottom height is model top. That's important. So passes, I am gonna do multiple passes. So just for a nicer finish. And we will do 0.5 millimeter passes, and we will use some of these other things. So you got pass extensions. We want to do that. So if you hold over it, look, see how that has a wave. So if we make this say 25 millimeters. And then we click simulate. You see how the path goes past it? This provides a nicer clean material. So let's simulate this item. And that's something you should do for every step as you simulate it. That way you can see if there's any material that you're not removing that you're supposed to, or if you're crashing. However, we can speed this up a bit. Let's speed that up. And then at the very end, you'll see the outline of the model. Alright, that's great. So that one passes simulation. Now so I also label these, so this will be lid top. And now for the next operation, I want to drill holes. So we're going to click on drilling. And I believe all of these are the same size hole. I believe they're all 3 millimeter. Actually, no, they're not. Sorry. I need to do 2 different ones. Alright, so these 4 are going to have, I usually don't mess with that any, tool. And those are 3 millimeters, so I need a 2.5 millimeter drill. See what I got in here. This will work fine for example purposes. And then now we go to our feeds and speeds. And our heights, first thing we check on the front, just make sure your heights are right. See, our heights, we don't want that. We want the height to be the model top. And you'll see why in a minute. And the whole bottom can be the whole bottom, that part's fine. You will want to click that button. So what that does is, since there's a small V here, to ensure that the hole goes all the way through, you just click that and it pushes it through. And then we click on cycle. Since I'm using high speed spindle, I always just click deep drilling. It just seems to work fine for what I do. So some of this is just, you do what works for you. Alright, so that hole's done. We're going to do another set of holes, which will be the mounting holes, since these aren't threaded. These will be 3.2 millimeter clearance holes, which I believe I actually have a tool in my library for that. Yes, right here. Click that. We go to heights again. We want model top. we want to break through. And heights again, we want to do deep drilling. And leave everything else is fine. And now we do another simulation. And click play. And everything looks about right. So now I click exit. Now we're going to do the pockets here. So under 2D pocket, click that, this, and this. And then you see how when you click the arrow it switches it? You just want to make sure that the pockets are blue, not the rest of it. End mill. This one's going to need to be tiny. Let's see what I got for flat end end mills. We'll use a 1mm. And then, let's see here, bring that up to 12,000 RPMs. Flood coolant. We want that stuff's all fine. Passes, I don't really care, it's a counter bore. Multiple depths is what I do care about though. Let's do a 0.5 millimeter. And compensation's fine. Everything's good there. Linking, everything's good. I should check a ramp. Yep, you want a helix. Okay. Heights, again, you want stock. In this case, we want model top. You gotta be careful with this. If you do all this work before you surface, you can use stock top. But since we surfaced it, you want to use model top. And then the bottom is selected contours. That's right. And then it should work. It does. Alright, so let's click on simulate again, click play, next. And then you see how there's counterboard holes now. Right. And we're going to use that same tool for this portion. So I am going to use you can use a few different things. You can use slot. I don't really like it. I just use 2D pocket. So for all of these, you just gotta make sure you pick the bottom one. And the nice thing is when you go to do the operations, since I'll be using a what's it called? Ah, dang it. I did it. I hate when that happens. Sometimes it gets bugged. So when you have the same tool, you don't have to try to keep your tool operations together. Reduces tool change, and also you don't have to pause the program to go between them. And we're still using that end mill. It's got all the same features from last time. Flood coolant, geometry, we're good there. Heights, and then stock top. Nope, we want that to be model top. Select contours. Passes, we want multiple depths. We want 0.5 millimeters because it's a tiny end mill. Linking, we want to do a ramp. That way it doesn't damage the part, or the tool rather. These aren't the most optimal. These are more for like home people machines, so not for like large industrial. So that's what this audience is more for. So don't really worry about the passes here, because this is all stuff that you would if you're using a big machine, you wouldn't worry about such things, as you'll have a more rigid system. But I figure if you have a more rigid system, you're probably not watching my videos. Alright, we got two other features we need to conclude on this portion. The first is we need to do a round over, so another 2D contour. And this one's easy, you just click that button right there. This one we will use a 1/4 inch 3 flute that I have that just chews through material pretty quick. I just need to find it. There we go. And that's good. Sandwich it right. And then model top. And then we want multiple depths just for completion, but I know this one can do 1mm depths, no problem. Lead in, we do want a ramp, because not ramping gets ugly. Click OK. Again, you simulate, and then hit go. And that part's done. And we got one last item to do, which is a chamfer. So 2D, and then we click on chamfer. Select our tool. Click on my tools. I got a chamfer mill in here somewhere. There we go. 6mm chamfer. Click on that one. Heights. Model top. That looks fine. That's fine. And you'll see how there's an error there, because sometimes what happens is you get, it doesn't like that. It really wants you to make a sketch. So we go back to our design. Click on here, click that, and we're just going to project this outer line. Which is actually honestly easier to do it from the bottom. Just click this, this. Here. Click OK. And now you have a sketch. Go back to manufacture, and now that sketch is there. So we go to here, we edit it. Go back to geometry, uncheck that, and now check the sketch. And we want to sketch the outside. Then check your heights and make sure everything looks good. Now you have a chamfer. Now you just have to play with how far you need to go. So that just depends on what kind of chamfer mill you got. And then I know that that's my contour, but I need to go down, and I believe it was 2mm, so we go -2, and then we will see where that's erroring out. And we'll just set that back to 0 then. Call it. Let's see. And that's 1mm there. 2. There we go. And now you have a chamfer. Oops. So we click here, click simulate. And then we click play. Next, next, next. 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 And now you have a chamfer. Looks pretty nice. Alright. So side 1 of this operation is complete. So we can go into our model and disable that sketch. So we don't want to see that sketch. So now we click the same thing. We click on setups again, right click, new setup. And then we leave that alone. Rename this one to lid bottom. This one's actually a lot easier to do this side, as it's only got a few different features. And then you do need to be cognizant of the orientation though. So before it was in this corner, so when we flip it, we want this corner. So we edit our stock, box point right here. And now we gotta play with some things here. Since we flipped the part over, we need to adjust the origin. Which we select our X and our Y axis. So X axis we want to be this. Y axis that. Stock point we gotta reselect to here. And we want to flip our X-axis, and now everything's happy again. Stock, we leave it from previous machining. That we leave alone. And this one's actually pretty easy. We've got 3 operations really we do. Or 4. But we use the same tool for most of them. So we're going to not worry about facing. Actually, no, we'll face it anyways. Let's select our tool. It's just good to face everything. And then we select geometry. Alright, we got that selected. Stock top, bottom height, good. Pass extension, make that back to 25 again. Okay, and we want multiple depths. Let's do 0.5. And we're good. We can see that from there. Alright, so next operation we want is a 2D pocket. So we're just going to select that. We're going to select our tool again. So we go back to that tree flute. We're going to click on model top. And then we need to look at them. So see how the blue line is at the top of the model now? That's what we want. And then selected contours. And then we want a helix entry. That's correct. And when you go back to passes, we don't care with that. Depths of cut, we want 1 millimeter. And you'll see there's passes there. So then we do another 2D pocket for this pocket. And then same tool, so we don't have to worry. Passes, multiple depth. No, we want this one, I believe. I don't think it really matters for this one. I think that one's only 1 millimeter deep. And then everything on there was fine. Everything's happy there. And then finally we have another 2D pocket. What we're going to do, we just click here, click on model top, no stock delete, multiple depths, back to 1 millimeter. And then we need to go back to this one. I screwed up the height. No, oh, was it? No, actually, sorry, it was this one screwed up the height. So I need to go to edit. And that's why you always gotta be careful. If I had a automatic tool setter, I wouldn't have to worry about that, because once the height was determined on the first item, everything else would be offset and figured out on its own. So we are going to click simulate now. See what this looks like. Let's skip that. Okay, got the interior down there. Alright, and that looks like a part so far. So now we have to do the same thing we did for the last one. So we need to go back to design, click on make a sketch to right there. Then we're just going to click P for project. And just to be lazy, we're just going to click that. Click finish. Click on manufacture again. We're going to copy this tool path, the chamfer one we just did, and we're going to paste it, and we're going to edit it and select our geometry, which in this case will be that line. Click OK, and it's all done. So now we will check this simulation again and click play. And just skip and see how you have a chamfered part. We'll get rid of that sketch again. And what we'll do now is from the top we will simulate the entire part. So we'll start on this side and hit play. So I'm trying to get it to look nicer for you. There we go. So when this is all done, you should have a completed part. But you'll see how all the different parts are made. And there you go. So that is one completed lid for your pie. And to do the bottom, you would do the exact same thing. These little pieces will be scrap, and I'm not going to get into fixturing since that's beyond the scope of this video, but this is it. And then if you want, what you do then is you'd click exit simulation, just click home just to make everything nice and happy again. And you would just right click this, you'd click on post process, you would name it. So in this case I will name this pie lid top. Everything is all set up. Click post and it'll show you everything you're going to do. Click successful. Then you'll do the same for this one. Click post, and the name of this one, pie lid bottom. Click that, shows all that done. What's going to happen there. And then you're done. And then you click up here for your programs. And sometimes if you're not using multiple offsets, don't worry about that warning. That's because in the what's it called, configuration, we're not doing that. We are not doing multiple. So remember when we did the setup here in the post process, we aren't using multiple work coordinates offsets. So that's why it gives that sometimes. It's not something you have to worry about. As long as it still uses G54, you're fine. But that's how you build a lid for a Pi. If you have any questions, don't hesitate to ask. I will probably do one more video discussing the simulation feature. I'm not sure though, as I think that's more of a paid feature and kind of beyond the scope of what most YouTubers discuss in the Fusion 360 world. I will probably talk about it more later once my paper has been published that I'm working on for a conference, as it's discussing using tools like this for finite element analysis for manufactured polymer parts. But for now, hope you liked it. If you did, give it a thumbs up, and I will talk to you guys next time. Bye.